can't invite him back later. So, okay, we'll do that. So let's get started. It seems to be around the right time. So welcome to Build. Welcome to one of many sessions on C++. And in particular, I'll be giving two sessions, this one today and a second one tomorrow, specifically about using C++. And they both have really the same theme. They have the theme that forget what you might have heard or known before about C++. Writing modern C++ code is clean, it's safe, and it's fast. Now that may mean that there's some stuff we used to know that isn't true anymore that we'll need to unlearn. So there's two parts to it. This session is talking about how writing C++ to target the WinRT is clean and safe and fast, just like in any of the modern languages. Tomorrow, we'll have another talk where I talk about how using ISO standard portable C++, also across platforms, across compilers, is also clean and safe and fast. Notice I'm not even saying fast and fluid. You know that one by heart by now. Okay, let's get it off our chests. All together now, fast and fluid. Fast and fluid. Okay, if you remember anything from this conference, that will be it. And there is no language that has loved that more for a longer time than C++. So let's talk about an overview of what we're doing, and then I'll spend most of the talk talking about the language extensions that we've done in the C++ compiler to be able to author and consume and use all this wonderful, rich WinRT goodness. Then I'll have just a few slides to give you a sense of what's happening on the library side, because there'll be other talks that talk in more depth about those things, including, I know some of you have already asked, how do I map collections from the STL to WinRT collections? You'll get a 3-slide answer and a deeper dive in other talks. And then, as time allows, for Q&A. So let me begin with an overview. You've seen this slide before. It's a key slide, and in particular, the part that I want to really show here is that we really mean it when we say that C++, C# and Visual Basic, JavaScript and HTML are all first-class citizens on this platform. If you want to write your application entirely in C++, go do it. Bob's your uncle. If you want to write heavy performance and parts of your application where flexibility and power are very important in C++, and the rest in C# with maybe a XAML UI, go nuts. That's what the tools are here for. In particular, in a Metro-style world, there are lots of combinations, but let me just focus on 3 in particular. First of all, Metro-style apps that are hybrid apps where you have, say, HTML5 and JavaScript on the front end, backed by the application logic and the guts of your application, doing the heavy lifting in C++. Or you might have a similar model where instead the UI is XAML, or you might be doing a game where it's all DirectX and C++ and none of the XAML or JavaScript at all. Any one of those works fine, including with other languages as well in combination. That's certainly not an exhaustive list, but all of these are first-class supported citizens. So just to give you a sense of it, before we look at a lot of code, Vikas, if you can do this with turning your mic on very carefully, would you like to give a welcome to Vikas? He's going to be showing us C++ and Metro app. And unless you were in Vikas's talk, I believe it's number 4.
It was right behind.
Oh, there you go.
There were a few people there.
How many of you were in Vikas's talk just before this one? Okay, quite a few, but not the majority. So please show them an app that maybe otherwise that most of them haven't seen before, written in C++.
All right, so there's my start screen. The app is called Magical Music. Just going to tap it. It comes on. It's the multi-touch piano app. How cool is that? You can select something. It plays the song that you selected. You can choose any of the songs. What I'm going to do is, in fact, try to play along. Stop playing. It's playing 2 songs right now. Demos, this is how they work. But let me minimize the sound of it. So what this app is doing is, it's XAML and C++ together. The UI is written in XAML. The code behind is C++. What we've done is, we've used the WinRT APIs to do some C++ processing. Let me shift back to Visual Studio over here, just to show you what it is. As you can see, this is a XAML-based UI. We have a rich designer now in Dev 11. So everything that you could do, if you're familiar with C# or WP7 development, you have a great designer, XAML-based designer. You can do your design in it, but this is all C++ along the way. So if I were to search for something with x:name, something called scroll viewer, it's in homepage.xaml. Let me go to show all files. Let me go to debug folder, and let's search for homepage.g.h. Let me open that up and search for scroll. Did I type it right? Man, this demo just won't work. But what happens is the XAML gets compiled into header and C++ files in the code behind. These are the generated files. So if you change any of the XAML parser will kick in, and it'll override the G and G.h and G.cpp files. So what I want you to take away from that is, this is the native stack all the way, right? So you're writing in XAML, but this is the native stack, the entire native stack.
So let me get that right. So you're writing your XAML. That goes to C++ class types, actually ref class, which we'll talk about in a moment. So these WinRT types. But that's native code, and you can debug into it, and you can debug into the code itself, because you were showing me that earlier. And when you say that's all native code, I never have to leave that native environment. It's all there. Now, but wait a minute. I thought you said that all the XAML is being processed into these C++ classes, which I'm also adding to. Do I have to worry about writing in between if defs and to round trip with the tool? Make sure you don't edit anything outside these lines. That's what we're used to.
Are you talking about partial classes there?
Oh, you have partial classes in C++ now? Oh, wouldn't that be wonderful?
So we have partial classes in C++. I can open up one of these, and if I see somewhere here, my search is not working apparently on my page. But these are these are partial classes that get declared, and later on we close them out, such that the compiler now thinks, okay, these were declared before in XAML, which gets compiled into the generated files. And with C++, when we write the app code behind, that's when the whole file is seen as a whole, and the compiler takes it and builds it for you. So this is the C++ stack.
So now, as a user, I'm going to interact with this application. And somehow a lot of the XAML, a lot of the infrastructure is going to do work for figuring out what the clicks are. So how do I connect to that?
So what we do is, there is a key tapped event that we get. So the XAML listens to events, right? So if I tap on my screen, I'm not going to try to show anything in code. It's just not working with me today. But I could subscribe to events such that when the event gets fired, I catch that event in my C++ code, and I can make sound. So in this particular app, what we're using is, we are dropping back actually to the Wasapi APIs, which is your Windows Sound APIs. These are your Win32 APIs that you've known and used for all these years, right? You can still use your WinRT APIs side by side, and you can handle events as you just talked about, the key tapped events. You can grab that event. You can say, okay, I want to play this using the Win32 APIs that I'm used to, and your world is just as good. You're still using C++ that you've been used to all these years.
So from C++, I've got a modern XAML UI with partial classes and round tripping that I can edit and extend, and it just works. And I can use WinRT types for sensors and for connecting to all of those things. And I can use Win32, just as I've always done, to capture audio streams and process them. And it just works?
It just works. So you must have seen Alesh yesterday. He talked about using the Boost library. One of our colleagues, Ali, in the back, has used the Bullet library to do some physics engine work that he's been using as well. So all of your libraries that you've been using before, they just work.
Well, thank you, Vikas. Shall we give him a hand? Thank you very much for showing us a bit about that application.
There you go. You're back.
Now, this is C++, so it has to be hard. So that's what I'm here to tell you, is no, that's not the case. No, you are not going to see cascading checking of H results, even though all the WinRT stuff is built on COM taken to a new generation. It's all reference counted, it's all native, but it is not your granddaddy's COM. It is not the old style of dealing with C++ and dealing with the fragility of the way the code often used to be much more verbose and you had to take more care. Rather, sometimes it's hard to tell the difference between C# or C++ or other modern languages. So what we've done is taken a set of language extensions that surface this. It allows you to consume it, allows you to author these types. As Alesh mentioned, a lot of what you've seen is already built, all in C++, the stuff you're going to be consuming, although you can consume it from any language. Everything's automatically reference counted. It's exception-based, deeply integrated with the STL, and all of this in an ABI-safe, module boundary-safe environment. What does that mean? To the language, what it means is that we've had to extend in 3 key areas. So when we took a look at this, we did not just decide to clone something we did before. We actually took a fresh start and said, okay, here's this new WinRT thing. It's its own new thing. How are we going to be able to express that, consume it and author it in the C++ language with extensions that are as clean and minimal as possible? And it turns out there are 3 things you need to bind to when you're going to bind to a foreign type system, a foreign object system. One of those is the data types. So WinRT knows about reference types, value types, it knows about interfaces, properties, events, generics. So we've got to surface those. But second, you need to deal with allocation. In particular, it's not just a plain old malloc or new. It's a reference-counted new, a safe one where lifetimes are automatically managed. And you need to deal with talking about those things with a new pointer declarator. So I'm pointing to something that's safe, and I can just stop thinking about it. I never need to delete it. Once you've got those, here in one slide, you've got all the language extensions that you're going to see for dealing with, which we're calling C++ component extensions, C++CX for short, but most of the time we don't even use that name. It's just some extensions in C++ where we're using C++ to access WinRT. When do you use these? So the rest of this talk is all about the details of what it looks like and what the code looks like, but this is the guidance slide. So when do you use these? It would be a mistake, and we are absolutely not telling you to go rush out and say, every class I ever wrote should now be a ref class or a value class, and I should just not use those old standard things anymore. Not at all. Pish tosh. What you should be doing is writing your C++ code, if that's the language of choice, just as you always have with absolutely no change. On the internals of your boundary and on the surface area of your boundary that you're presenting the usual way that we always have to other languages, say through a flat C interface, for native callers and callees. But now, where do WinRT types come in? Again, they come in on the boundary. It's when you want to talk to something that is not necessarily C++, compiled with the same C++ compiler and switch settings. You want something that's ABI safe. So for example, you'll notice that that green area goes in 3 parts. It goes around the box. I'm going to write my module internals in C++ as always. But underneath, if I'm going to go and call down into Windows using these new WinRT APIs, guess what? I'm going to use WinRT types to do that. Because now I'm getting to talk to the Windows API, not through some flat C handle-based API, but with classes, interfaces, properties, events, all these cool things. Perfectly safe on module boundaries, ABI safe. Now that's the bottom part, talking to WinRT, talking to what Windows gives you. But now you yourself may want to expose a surface area to other callers. That's what we do. In C++, we're often used to build libraries. So now we want to present a surface area to other callers, not necessarily built in C++ using the same compiler. And today, what do we have to do? We flatten our API to pointers and handles and integers. Now on Windows, you can also surface WinRT types, and then any C++, Visual Basic, C#, JavaScript caller can use you just as cleanly. And with no fuss, no muss, with full integration. And on the side, hey, if you're developing your application in several modules, and you actually want to talk in classes and objects over a boundary, you can use them for that too, even within your application. Now remember, like anything, as soon as you cross a boundary, you're going to pay something for it. So make sure that you're going to get what you pay for, so make sure that that's what you want. But that's a perfect place where you're supposed to be using these types. It's not to replace all the classes you ever wrote. Just go use your language as normal inside your module. This is on the boundary of the module where you consume and expose with other languages. So now let's talk about the language extensions that we did. In this first slide, I could stop here and you would know everything you needed to know about consuming WinRT types, WinRT interfaces, WinRT facilities, because all you got to know is hat and ref new. The way that you allocate a new type, say that person is a type that WinRT gives you. The way you allocate it, I'll show you even simpler ways on a couple of slides from now, but the basic way you allocate it is you say ref new. It's a reference counted new. That returns a hat, not a star, and that's my pointer type, which I then go and dereference the usual way with arrow, and think of it as a reference counted smart pointer. How many of you have done COM in the past? How many of you have heard of COM? It seems so 1990s, but it is oh so relevant today. So if you've done COM, you know about, say, CCOM putter. Well, you know about doing your own add, ref, and release, and we don't really want to even think about that world. Right? Good, just making sure. We hate that, bad. But even with ATL and with CCOM putter and other kinds of smart pointers, we did a very nice job. We could use exceptions. There was exception safety. But the syntax was a bit extended, because instead of just saying, like in C# person P and then P do something, CCOM putter of person equal, and then you had to do a little more typing. Not the end of the world, but people don't like angles for some reason. Well, think of hat as CCOM putter baked into the compiler, baked into the language, and before you say, well, what's the point? We already had CCOM putter. Once the compiler knows about it, boy, can we make it fast. In particular, you will never get an addref passing this parameter on the stack. A hat is a parameter on a stack. So we know how to make it fast. We're already doing a lot of that in this release, and we will continue to do that, because here's a nice abstraction that we can engineer behind for a long time to come. Is there actually an I unknown under all of this? Actually, yes, but what you'll normally see is I inspectable, because I inspectable is one below I unknown. So this is not a talk about how WinRT is arranged, but you'll see a slide in other talk which will tell you about that. Yes, there's an I unknown up there, but you won't actually deal with that. That's low-level COM. It's actually I inspectable, which is very much like system object, just conceptually if you want to reach over to a different object model, but it's all native. So ref new instantiates, activates this runtime class, and then you just use it. And this little code snippet just shows how you do that with reference counted smart pointers. And the object can outlive the scope because there's still a pointer pointing to it. When you set the last pointer to null or it gets destroyed, reference count drops to 0, automatic cleanup. Perfectly safe code. That is exception safe. You never write delete anywhere. And that's modern C++ for WinRT. Now, if all you're doing is consuming WinRT APIs, you'll never see more than that. But we're C++. We built a lot of the stuff in WinRT. We would like to extend it. We're the power and performance language. So let's now talk about going much further. The first thing you'll want to do is actually create a runtime class, create a reference class. And so the way you do that is you say ref class person, and then you write your methods as normal. Now, in addition to the normal public and protected and private accessibilities, you also get internal, and which may be familiar to you. It has the same meaning as anywhere else you may have heard it before. In your public surface area, which means public or protected, all you get to do is traffic in WinRT types. So with hats to other ref classes or value classes or interfaces. So the public and protected areas, they get projected to metadata, they get consumed by other languages, and so they have to stay in that world. They are WinRT types only. But you can do whatever you want in the internal and private parts. And you just write the code, and it just works. You don't have to split things apart. You just write the class, and we'll enforce at compile time that you can only use the ABI-safe ones in the projected part. By the way, you'll notice another place public appeared was on the ref class itself, because, of course, this is getting projected to metadata, and so you want accessibility of the class itself, and that public ref class means it's public in that assembly in the WinMD file, which I'll have a slide on near the end just to complete the picture of exactly what goes to WinMD. But here I've created a person as an ABI-safe class, safe to use on modules, never needs delete when it's allocated. Any language can use it, very efficient, and the usage at the bottom, those last two lines, is exactly what I said. Anybody who wants to consume it in C++ never needs to look at more than ref new and hat, and that's all they need to know. Of course, classes implement interfaces, so that's the next thing to talk about, because we want to talk about base classes and abstractions and virtual functions. So the way you do that is, again, you define an interface. You can make it public or private, and it's an interface class. And notice you don't have to say on iAnimal, you don't have to say virtual void play paren equals 0 semicolon. You can write equals 0 if you feel like it. We're not going to stop you, but it's redundant. It's implied because this is an interface class. So we get to say what the defaults for this kind of class are. Also, virtual is implied. Also, no, you can't have data members. You said you wanted an interface, so that's what you are now authoring. So it gives us a very nice, clean way of saying, hey, I want an interface. And it's just another kind of class. The way I use it is now on the right-hand side, I'm going to now have one interface conceptually derive from another. So interface iFeline is an iAnimal, and then maybe I've got a cat, which is an iFeline. And then on the left-hand side, I can then say that the iAnimal hat gets a ref new cat. And then I can just call play or do whatever makes sense on that interface, and it just works. So I'm going at it in a bit of detail just to reassure you that, yeah, it's really just classes and interfaces, but they're ABI safe. And they can now be consumed by any language. Now, I said before that all you really needed to know was hat and ref new, and that's true, but often you don't even need the ref new and hat parts, because you can take any WinRT type, say a database connection type. It's a very common one because it happens to own a resource where you might want to do this, but you can do this for any type, feline, cat, whatever you like, and allocate an object on the stack. It's just conceptual. Now, under the covers, because we're in C++, so we can handle the truth. So under the covers, what actually happens is it's the same as if you'd written hat and ref new. What's actually physically on the stack is just your C compiler built into the language, and you get this COM-activated component out on the heap, reference-counted heap. But that's just an implementation layout detail. This happens to be the way the compiler implemented your intent. All you said was, I got a database connection. It's called DB. Let's go use it. And you call .setName, .connect, or whatever you'd like to do with normal object syntax. And if you wrote a destructor for that class, it will get invoked automatically when you leave the scope. So very nice, very convenient, and just exactly what you're used to in C++. Now, in this particular case, I'm showing stack allocation, stack semantics. But you'll notice the title of the slide actually also says member. You can put one WinRT object by value in another one. Now, they're not actually laid out in memory together. Again, it's the same thing. One stores a hat to the other that's separately allocated, but the semantics are the same. The layout is an implementation detail. And it gives you all the rich usefulness that you're used to with any class, any type in C++. You can now take WinRT types and put them in all the same places with all the same semantics, as this has been fully integrated throughout the type system as just another type. Now, there are some things that go beyond what are available in standard C++, at least today. The ISO standard has had things like properties and events proposed, but none of them have yet made it to be accepted. So in the meantime, what we have is native properties, native events, and native delegates. So let's talk about those. How many of you, by the way, are already pretty familiar with properties, delegates, and events from somewhere, any language? They're very common. We've also done them with libraries in C++, so that was most of you. So I'll go through it at a summary level. A property is as if you had a data field, but it's really functions backing and hiding the storage. So you're not really depending on the layout of the class, or that there really is a field, a data field at all. So in this case, I may have a property string hat name. Now string hat, which I haven't introduced yet, that's just the way you talk about WinRT strings. So some of the basic things you'll use in WinRT, fundamental types, string is one of them, so there's a string. And we always have those. They're immutable. They're always reference counted immutable on the heap, so you have a hat to them. And there's my property name. Now that's not a string hat field, but it acts like one. It has a getter and a setter. And by default, if all I write is property string hat name semicolon, what the compiler does is it actually does create a field hidden of that type, and then creates a trivial getter and setter to get and set that field. It's just convenient syntax. If you want to do something fancier, then you could write the getter and setter yourself. And so here are some examples of how you might do that. And then define your own backing storage, which might not be a field of that type or a field at all, and do whatever makes sense to back that property. And then using it is the same syntax at the bottom as if it were a data field. You just access it as though it were a member. And the usual rules apply for when you call the get and when you call the set. Now, we talked about properties. The next thing that you usually talk about is delegates, which are type-safe function pointers, because then you show that events really can be thought of as properties of type delegate. You just add and remove and raise them instead of getting and setting them. So we talked about properties. Here are delegates. Think of delegate as a boosted and interface-safe std function, if you're familiar with that, or a C function pointer, but it's safe and it's module-friendly. All I say is, again, whether it's public or private, then a delegate followed by the signature of the function, something I want to be able to call with these kinds of parameters that returns this kind of thing. Now, what can I then connect this to? So far, all I've done in that first line is done the moral equivalent of declaring a function pointer. Well, it turns out that although in C++ and C you can only bind function pointers to a few things like function, and you have to go to the C++ standard library, the very latest one, to be able to do more, like have an std function of some signature to be able to bind other kinds of things to it. All of those things work with delegates. So for example, the first thing you might do, and this is getting increasingly common, so if you're not familiar with the syntax already from C# or from having used it already in C++ since our Visual Studio 2010 release, you will get used to it because it's so convenient. If you don't love it already, boy, will you love it. I might be accused sometimes of going overboard on this one. But lambda functions are incredibly game-changing. So let's bind a delegate to one. So there's a C++ lambda function. That's what those empty braces mean. And you can say more in the braces to say how you capture local variables. But all it is say, create me a function object here with this signature and this body. And you write the function in line, very much like C# lambdas, JavaScript function. And I'll assign that to this property change delegate type, and it just works. That is a native C++ lambda. That is not a WinRT thing. That is a native C++ lambda being used to initialize a WinRT delegate type. And all I said was ref new delegate type, and then write the lambda the way I would do in standard portable C++ code. Of course, I can also use free functions, like create a ref new property changed from some free function, UI property changed, or from a member function, where I pass this pointer, or from bind expressions, or from anything you want, anything invocable, I can connect up to a WinRT delegate. Now, as soon as you do hook it up to a WinRT delegate, now it is module safe, and you are getting that extra strength. So when you reach for it, it's there. Otherwise, you're just in plain standard C++, and it just works well together. And then finally, no matter what you did, you just invoke it as if it were a function, like p visible false, and you're done. So putting those two together, properties, delegates. Now, what if you have a property that's a delegate type, and you really, instead of getting and setting it, you'd like to add, remove, and then fire it off, invoke it? That's what an event is. So you can say event, and it always has to have a delegate type. So a delegate hat type, my event name. And then you could either have a trivial event where where you just have a delegate of that type and write add, remove, raise for you, or you can take over writing add, remove, raise yourself. And then when you use it to subscribe, there's actually two ways to do it. One is you can call add explicitly, or you can call the overloaded plus equals operator. Just one thing to keep in mind here, when you do this, and this is not just C++, this is in all the languages, if you want to then later unsubscribe, you have to do it via a token you got when you subscribed. So just be aware of that. You don't just pass another same thing that you pass to add. What you'll do is you'll remember that token you got when you added it, and then pass it to remove or minus equals. And that's how you can add and remove yourself, subscribe and unsubscribe to events in a way that WinRT will recognize universally. Now, because we're in this business of providing this nice class-based, this OO interface virtual function-based module-safe facility, because we could never do this in a module-safe way in native code before. You couldn't even use stood string on a module boundary because you don't know what its layout's going to be on a given compiler with a given phase of the moon or different switch settings. These types you can. They're class types you can use on the surface area of your module safely, in an ABI-safe way. Well, as soon as you've got classes, man, you want exceptions. Because how else are you going to signal constructor failure? Don't say, by returning an error code through an out parameter from a constructor, bad. No, we learned long ago that's not the answer. If you have classes, you want exceptions. They go together like bread and butter. And you have to have the two. So we also have ABI-safe exceptions, which you'll hear a lot about in WinRT. You've seen them already. And all you do to report errors is you throw and you catch. You throw and you catch. That's all you need to do. And when you throw things, you actually throw, notice ref new, you allocate a new ref class type. And we provide you several that may sound familiar. Invalid argument exception. You will not be trafficking in those H results, in those E underbars, because now we actually give you types for many of these common ones, which you'll see at the top of the screen. Many of the common COM exceptions really are exceptions now. And if there's one that doesn't already have a type and you want to throw a particular H result, say for compatibility with some COM code you already wrote, and you want to preserve the knowledge of that H result, just pass it as a ref new COM exception with whatever that number is. If you want to catch all WinRT exceptions, the first note bullet at the bottom is how you do it. You catch platform exception hat. Platform exception is the base of all exceptions that are WinRT. If you want to catch everything, it's catch ... But if you want to catch all WinRT exceptions, it's catch platform exception hat. And in this release, you can't further derive from exception or make your own. These are the ones you can use COM exception for any H result and the ones that are mentioned here. If you were paying attention earlier, and I don't know if maybe you heard this already in another session, but earlier in this one, I happened to just, in the course of rambling through a sentence, mention native generics. And if you're wondering what that was about, then I can understand that, because we already have native genericity. It's called templates. We know how to do this, solved problem. So why are we talking about WinRT generics? Because generics are different from templates, and it's not either or. In C++, you can use both. So the way it works is, I'm going to talk about C++ templates on the next slide, so we will talk about them. We still love them to death, and they're still very useful. What WinRT generics are is, for the first time, we have the ability not just to talk about classes and interfaces in an ABI-safe way, to actually have a native API that we can surface to many languages that talks about classes, class types, and works. But also, we can write generic interfaces. So for example, you can parameterize an interface like iPair, just to pick a straw man example that's easy to see on a slide, with iPair that has first and second properties, and those are parameterized on the types of the two types that are passed to instantiate that generic. Now, to implement it, say I want to then actually go and have a ref class that uses that. On the right-hand side, you see ref class. Say I want a pair string int class. It inherits from iPair of string hat and URI hat. So the pair string URI type implements that instance of that generic interface. But I was actually able to talk about a generic interface. And WinRT and metadata understand that. Now, when I use that, how does it work? Well, in the using part at the bottom, you'll see that I can have an iPair of string hat URI hat, and then I can call some function getURI, which actually returns this class, pair string URI. And once I don't necessarily even need to know that class exists, because I'm just using it through this base interface. And then when I access its first and second members, and I use the standard auto to deduce the types, they come right back out exactly what I expected, a string hat and URI hat, all of it just works together. So that's native generic interfaces and how you author them, implement them, use them in C++. But where do templates come in? I mean, generics have the advantage that they're known to metadata, they're known to other languages. And so they're ABI safe, these generic interfaces. But templates still have an important role to play. I mean, they're very flexible. They're way more powerful than generics. Now, templates aren't ABI safe. Generics are. But templates give you all sorts of other things like specialization, compile time, compression, and all kinds of things that we've come to know and love. Well, they work too. In fact, all of this has been designed to work together so that we can create these new types that then merge and are independent and integrate evenly throughout the existing C++ type system, including exceptions, including templates. So I can have a templated ref class. Now, don't get too excited. Because, of course, WinRT has no clue what templates are. C# wouldn't know what to do with it. JavaScript would say, pardon me. So templates don't go into metadata. But this is C++. I can templatize just about anything. Andrei Alexandrescu has proved that to great effect. But that's another talk, or three. But what I can do is have a template that is a ref class. So in this example, I see a ref class that's templated on two things. In fact, it's a ref class pair that then I pass those template arguments as generic, template parameters as generic arguments, so it all works together smoothly. And the way to think of it is that every instantiation of this ref class template is a ref class. That's all you need to know. So you can't just take the template itself and export that and imagine other languages would know how to deal with it and instantiate it. That's not how it works. But you have to instantiate it in C++, but every instantiation, including now I have a ref new pair of string hat, URI hat, there's a ref class that everybody else knows what to do with. There's a ref class. I know what that is. May have a funny name under the covers with some mangling, but everybody knows what that is. And that's how we made C++ templates work great, just as they always do in the rest of C++, also work with these WinRT types. And every instance, every instantiation can be exposed and used directly, seamlessly by any of these other languages. Other languages can't instantiate the template, but they can use whatever we instantiate, and they'll never know, and they can use it perfectly well. Now, to make all of this work, of course, we have to also work with the metadata. So the way that this has been built is WinRT has drawn the best from many of these different environments. So we've used the metadata format from .NET. We built everything in WinRT as a great evolution of COM. And so it's still all native, it's still COM and reference counting, but there's this great metadata that lets us describe what we're doing and enable great tool support, enable cross-language consumption and authoring. And that's all in these WinMD files. So when you author a ref class and you make it public and you compile that, we will create a WinMD file that contains all of the information any other language needs to know to consume that type. All the methods, the parameters, the interfaces it implements, any genericity about those interfaces, everything will be right there. Now, what if you're trying to consume somebody else's? Somebody else creates a wonderful WinMD that you want to consume. There's two ways you can do it. Go into VS in the Solution Explorer and add references, and then we'll pull it in. Or if you want to do it in code, then instead of pound include, you go pound using, and you give the WinMD file name, and that will have the same effect. To produce a WinMD file, all you do is you start from one of the wizards that gives you a component, DLL, that's a WinRT style wizard. You define public types, and we just do the rest. All of it gets projected as you compile. Now, I alluded earlier to partial classes. Until now, C++ has not had partial classes. And in this release, partial classes are only for WinRT types. But they're so important. One of the reasons why, certainly not the only reason, and you can point at others, but one major pain point and reason why it's been hard to develop nice round-tripping tools for C++ is often you're in the situation where you want the tool to generate some C++ code where you then add some code to it. And that's all easy cheesy if it's two separate classes, because then the tool can just go regenerate the class. But if you've actually got to put code into the same class, now you're in this hell of if-defs and trying to figure out, oh, please don't modify anything between these lines or bad things will happen. And nobody likes that world. It has worked, but it's not very friendly at all for users or for tools. The idea of a partial class is the tool in particular, although you can do this yourself, but it's very useful for tools, can simply create the code for part of the code for a class. Call it a partial class, just like .NET has had for some time now, and create methods, create functions in that class, create definitions that call other things that don't exist yet, and that's all fine. You then go and supply the rest of the class. You can have multiple partial classes, but somebody finally is going to say, okay, here is the actual ref class main page after all these partials. I'm going to supply everything that's missing, everything that's left, including implementations of functions like button click that the partial class implementation calls. And I can call things in the partial class implementation. And the semantics are pretty simple. If you take a look at this as source code, which is the way that we see it in the compiler, every time you see partial class X, then partial class X, then a little few million lines later, partial class X, and then you see ref class X. All these partial ref classes, and finally an honest-to-goodness ref class, it's really simple. It is as if all of the stuff inside those partial classes was written right there. So all of your name lookup will be done at the point of that you actually define the ref class itself. And that answers 99% of the questions about what are the semantics. And the rest, for the other 1%, the answer is, and you can find it in the documentation, but the answer is basically what you would expect. It works the way you would expect. So, but 99% of it is answered just by saying it's as if all of those partial classes are written down here when I finally said ref class and defined the real thing, the rest of it. So that's a tour of classes, interfaces, of exceptions, properties, delegates, events, all ABI safe, all great to use on the boundary of your application to talk to other languages, to consume all these wonderful WinRT things. And the code is really slick. You're not dealing in H results. You're not dealing with COM pointers and smart pointer types. To consume it, you just do hat and ref new, and if all you're doing is using WinRT APIs, that's all you'll ever see. And the rest of the next dozen slides we talked about are just if you're authoring all this cool stuff yourself, which is also easy. And in fact, one of the things I really like about what we've managed to do with this product is if you take a look at code written in any of the major languages, they really are equal, and they are just as clean because they're all modern languages now. The cruftiness that some of the languages have had is largely just disappeared because we just don't need to do that stuff anymore. In fact, many of the times as I've been seeing people work on the demos, they'll be taking C# code and just transliterate it to C++ code, often just line for line because that's the same structure. Or take C# XAML and just reuse it in C++ with fewer or no changes. And that's something to be proud of. It also makes your lives easier as you're taking assets you already have, as you're taking code you already have, skills you already have, and just using whatever tools that you like and are comfortable with, bringing them forward and building really cool stuff that I cannot even begin to imagine how it's going to change the way we use computers in the next short number of years. It's really an exciting time to be in any of these languages, and it's super great to see all of them have this first-class treatment and support, and have writing code in all of them, including C++, be clean, be safe, and be fast. So we'll talk more about that tomorrow when I talk about how that's true for C++ in general these days, because there's a lot of you who are coming back to it who might have been away for a while, so we have a talk for you. And also for those who might just be curious as to what's going on in C++ if you've never seen it before. So come to that tomorrow afternoon, and we'll talk more about that then. But before we finish and go to Q&A, I've talked mostly, like I said, about the language extensions, how to define these types if you want to author them. One of the questions that I know has already been asked at other talks that were like some DirectX talks and others where you would think, how does this even, it's not even related to what the theme of the talk was, but somebody wanted to know, so they asked the speaker, was, well, how do I use WinRT collections and C++ STL collections, standard collections together? How does that work? So here's a summary in 3 slides of how that is, and you'll find more details in Tarek's talk and other talks, which I'll reference at the end, as to how all of this cool stuff works together. The short answer in 1 line is they just work together seamlessly. Now, you want more detail. Let's take a look at a bit more detail. In WinRT, as you look at the collections APIs, some of the very basic collections that you'll see a lot are vector and observable vector. And if you're familiar with the standard C++ little v vector from the std namespace, it's very similar, except it's in an OO style with capital lettered and Pascal cased names. So for example, from the platform namespace, you might have a capital V vector of string hats, which is perfectly safe to use on an ABI boundary. Other languages know exactly what that is and how to consume them. And you say ref new big V vector, and then you can go and you can append to it, and that's just spelled with a capital A. And if you want iterators, in STL we would get iterators from that. A vector view, an I vector view, is like think of it as an iterator range. It's a way to navigate. It's an interface that lets you navigate. Okay, I want to navigate that vector. I just take an I vector view, and you can pass whatever you want that implements I vector view, and I'll be able to consume it and navigate it. Just like in native code, you would pass an iterator pair. Of course, because these are part of an object-oriented, event-based system, you can also ask for event notifications, like has the vector changed? Sometimes useful to know about. Things that the standard vector can't do. So there's a place for each one. Write your native code, native C++ standard types in the internals of your module, but on the boundary, when you want to talk to other languages, or if you have a need to have a notification for the event, the vector changed, so you just want to use the functionality of a certain type, that's when you use the WinRT types. So you'll see a lot more about vector and observable vector. Similarly, there's map and observable map. So this is a dictionary key value based lookup, and it pretty much does the same things. You call capital I insert with an arrow instead of little I insert with a dot. You have has key and remove. So some of the names are slightly different, but we all know what these are. And so WinRT provides these standard cross-language ways. So how do you use them together with your C++ collections and your existing C++ code? Well, here's how you do it. First of all, you can directly, without any kind of extra work on your part, navigate vector views and vectors and maps and map views using plain Jane STL algorithms with plain Jane iterator pairs. And the way that you do it is that every algorithm expects an iterator pair, and every WinRT container provides begin and end member functions. Now, they're not little b begin, they're capital B begin. Doesn't matter. Now, this takes advantage of a C++11 feature, a new feature in the new standard. In the new standard library in particular, do you notice that near the bottom left where we call std for each, the plain Jane standard for each algorithm that's been there for 15 years? Instead of calling v.begin, v.end, you might say, oh, look, here's Microsoft, and they have this extension where you have to turn it inside out. You call begin of v and end of v. And those helpers simply call the capital B begin. But I had to use this non-member form. And the rest is all standard, but I had to use this non-member form. No, actually, the non-member form is standard, and it's encouraged. That's the way you should always write the code now, is use the non-member versions of begin and end. We'll talk about that a bit more tomorrow. Because it's great for extensibility, including here. When you have another type that you want to make work and cough up a begin iterator, cough up an end iterator, and even if that type didn't already provide begin and end functions, you can just provide your own and then use it seamlessly with algorithms, and we're just using that same C++ idiom here. In fact, if you look at that bottom left code from those last 5 lines, the only line that has anything to do with WinRT is the first one that happens to say, I've got an I vector of int hat. The rest is all plain Jane STL code, C++ STL, using lambdas, using all the regular code. In fact, if you change that first line to be an std vector, the code would still work. It's exactly the same thing. So I can use WinRT collections, seamlessly consume them just like native collections. But on the other hand, I can also expose native collections. So on the right-hand side, you'll see conversions. If I have a string hat that I use on an ABI boundary, somebody in another language expects a WinRT string, but I've got a standard W string or a standard string. How do I do that? Well, we provide seamless conversion so that, and it's done in a safe way, so the rules are convenient, but not so convenient they're not safe, for you to be able to pretty seamlessly go both ways across that boundary. And you should be using the WinRT types only on the surface, only on the boundary, and that includes string. and use your own local types, native types, in the rest of your application. So my string can go to string hat and back and forth. Now, my std vector I have, my standard C++ vector, I can pass and initialize with a ref new vector of int from little v in that middle line of code, which is a standard vector. I could just immediately copy construct one or conversion construct one. And going the other way, I can create a little v vector straight from a big V vector that's WinRT safe. And that's just an example to scratch the surface, but it's really well integrated, not just in the language, but also in the library, so the code can work together pretty fluidly, so that the rest of your code continues to use your cool native tools, your language in the middle, and on the boundary, the WinRT types work seamlessly to be able to talk to other languages. Now, if you want to find out more, there's quite a bit here. If in the tools track, you'll also see the following sessions: 100 talking about code quality and code analysis in C++. There's a talk that we've already had, but is available on demand if you missed it. So all of these are available to you that will be put up so that you can see them. And so you've not missed anything yet. If you missed it, you didn't really miss it. A lap around Visual Studio 11 for Metro-style apps using C++. DirectX games, GPU compute. My talk tomorrow on modern C++ that only mentions WinRT for a slide at the end. So fair warning, but setting expectations. Because there's a lot of cool stuff to learn and be reminded about. And as you just look at all of these, and then also on the other side, the online talks that are already on Channel 9 that you can find for viewing, we've done a lot for C++ in just one product cycle. I was just saying to some people on the team several times over the last year, I can't remember any 2 previous releases where we've done as much in C++. And we're really proud of being able to deliver all of this, from C++ AMP with GPU computing that you'll hear about, to tool support with XAML, to tool support with all of the great work done on ALM that now has first-class C++ support as well, and for WinRT and Metro apps, which is the cornerstone of this conference and a really cool segment of the industry that is just getting started. All of it available right here from C++. So thank you for coming, and I'm happy to take a few questions. We have a few minutes left over. And if you want to actually get to the mics and I can hear you, in the meantime, I'll try to repeat questions.
Does this version support GPUs, or do we have to wait until C++ AMP?
Does this version support GPU, or do we have to wait till C++ AMP is in a product? I believe, is Daniel in the room? I believe that the C++ AMP is in this beta.
Yes, it is.
Or in this developer preview. So you have it available already on your slates. Yes. Yes.
Can
you turn on the mics, please?
I was looking through the API documentation, and I noticed that some of the APIs, they define the C# version as a system.string and the C++ version as just a string. And I was wondering if that's the same thing, or if it's somehow pinning it and proxying it when it goes to WinRT, or how do those types relate?
So the question is, I don't think the mic was quite on, so I'll repeat it. Why is it that we see WinRT strings in C# as system strings, but here we see them as just strings? Are they different? Each language projects them in their natural way. So I'm not the CLR expert to ask, so definitely ask this at a CLR talk, but they have gone through a lot of trouble to take a lot of the WinRT types and just map them directly with very little layering, sometimes none at all, just to map them into what C# developers are used to. And we map them onto things that C++ developers are used to. So think of it as a thin translation layer most of the time. Yes. I'll give some preference to people at mics. You made the effort to get up there.
So I was wondering on all these collection classes you were showing, do they have like the generic libraries in .NET with the underlying like I-enumerables and I-collections and stuff like that to let you deal with them in a more general way?
So where can I find out more about collections? So there is going to be more detail available in talks and documentation, but the short answer is that yes, you do get things very much like I-enumerable. In fact, if you think of many of these things, I-observable vector, I can't remember right at the top, because I'm having just a brain space on the exact name. It's not I-enumerable, I-iterable, I believe was the name that was chosen. So you will see a lot of direct mapping there and similarities, not because anything was slavishly followed, It's because it's a natural way to do that kind of design, collection design, in an ABI-safe way. Go ahead.
I've got two questions.
You get one.
Okay.
I know that trick.
All right. During the discussion on extensions, you very conspicuously didn't say anything about C++ CLI. And it looks very, very similar to what C++ CLI is. Besides the fact that it's all native instead of managed, what conceptual differences are there as far as how we would approach using this?
You just nailed it. Under /ZW, so you're right, I deliberately didn't say C++ CLI, and I will now say it. Thank you very much for uttering those words. So when we just started designing, I remember I said near the beginning when we just started designing these language extensions, so I led the design team that worked hard on how to surface this in C++. We tried a bunch of zany things all over the place, brainstorming. What's the right way to do this? Let's not just copy something because we did it. We'll draw from it if appropriate, but we're not ignoring it. But what's the right thing for WinRT? Let's make sure we've got a clear mind and aren't just slavishly following something. And over again, we realized we made some pretty good decisions with C++ CLI in terms of this is what you need to bind to a foreign object system. And so this is, you will see the syntax and you will think that's C++ CLI. We continue to support C++ CLI. C++ CLI has IntelliSense, again, in this release. We've invested heavily in that as well. So you might be happy to hear about that. But that's not in this talk, so pretend I didn't say it. Don't get too happy, but it's there. And so as you look at the C++ CLI IntelliSense, you will also notice that that's available when you go /CLR. That syntax maps to .NET types. And when you go /ZW, that syntax maps to WinRT types. And the only difference, the only place where we diverge, and there's a good technical reason to do it, is that we have, you might have noticed on the early slide, there was under allocation, there was a line for GCNew and one for refnew.
That was my second question.
Right. That is the only difference, and the reason we did it is to reserve the name GCNew in case we did anything else interesting in the future. Nothing planned, but it seemed like another useful tool to have. And it wasn't quite GC. That would be giving the wrong impression for what was really happening. And so that is the one difference. But yes, this is C++ CLI syntax, but don't think of it that way because it'll take a lot of people down the road of, oh, is this really just managed? Am I getting managed proxies and CLR spinning up? No, 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 no. Under ZW, we happen to use the same syntax. It's pure native, pure COM-based WinRT types, and the one difference being refnew. But everything you've learned and know applies. And because we did this again, now we have 2 proof points that this is a pretty good way to do language extensions and not keep doing something new each time. We've generalized the name, so we're not calling it C++ CLI. You might have seen the term, it was C++ component extensions or C++ CX. But mostly, that's only when we talk about if you really need a noun for this set of extensions, you can use that. Mostly we just think of it as here's how you do it in C++, in Visual C++.
Thank you.
You got a long answer because it was an important question, so thanks for pointing at the elephant over there in the corner. Yes, round robin.
So just to clarify what I think I just heard you say, GCNew doesn't actually do anything right now, it's just reserved for the future?
Yes.
Okay.
GCNew will not compile under /ZW. You'll have to say refnew.
Okay, gotcha. That wasn't my actual question. My actual question.
Okay. I won't let the next person do that, but I'll let you get away with that one.
Is the reference counting scheme what's used by the other languages also to make sure they release the WinRT objects?
You'll have to talk to other language teams for the specifics of how they do lifetime management, because if you have a garbage collector, they have different nuances for that. But the reference counting is all the same. They're just WinRT objects. They do their own reference counting, and it's fully standardized and baked into what WinRT is, and then we just project that. It's just how you author and consume it in other languages. But it doesn't do something different just depending on which language you're in, although a garbage collected language may hold on to something longer just because that's what it naturally does, but it doesn't change the way that reference counting is done for WinRT objects. Yes, sir?
If we're over in the blue Win32 native silo, what will we have available to us?
If you're over in the blue Win32 silo, you will have everything you could ever have imagined you had before. Everything continues to work. Plus, there are some new Win32 APIs, and the Windows team is the right people to ask about those. Obviously, a lot of the focus is on WinRT, and you can use and mix and match them. You know, if you think all this Metro stuff is a flash in the pan and not really interesting, there's rich Windows that's unchanged and is better than ever. And you get all of it in C++, plus now you get some more features that you didn't have before. If you liked existing stuff and you wanted IntelliSense for C++ CLI or a GPGPU, there's a lot there for you. If you think Metro-style apps are cool, you can also use this, but you can just use them together. Just use the parts you want. They're just more libraries.
Thank you.
Behind you at the mic.
Okay. I was wondering what the performance implications were with the automatic reference counting. Does it use like some sort of interlocked increment, or is there something a little bit more performant for concurrent-based programming?
So it's a very good question, because reference counting isn't free. Just like garbage collection isn't free, nothing is free, not even free lunches. So especially, when you look at smart pointers, standard shared pointer, I was going through that with Alex is in the room. Where are you, Alex? Wave. Yes, we were having a good discussion in Banff about that a month ago. And it turns out that by far the biggest cost is the interlocked increment. And you almost never can get away. That's why for a standard shared pointer, you better always pass it by const reference. It's just the right thing to do. Somebody should write an effective C++ book that mentions this. Because that's the new reality, always pass them by reference. Why? Because you don't want that add ref. Something else is keeping it alive, and that's safe 99% of the time. There's a 1% we should talk about. That's the native world with standard reference counted smart pointers the way they've always been done in C++. Now, remember I said HAT was a C computer baked into the compiler that we can optimize in very interesting and intriguing ways. And we will do even more in the future, but one of the ways we're already doing is you pass those things by value on the stack and we never add ref them. And there are many performance opportunities we have by knowing, the compiler knows about this important type and will do things on your behalf. So there are things that we know that we can do even more in the future, but the idea is to present you this interface, this model that you program to, that we can engineer underneath, but it's a simple model, a clean model, a fast model, because we can do a lot of optimization on your behalf that with other smart pointer systems, you would have had to think about and write extra code and constant references just to make sure that you weren't getting overheads you didn't need.
Gotcha. Thank you.
Yes, these pen pointers and GC root, these kinds of things where you have native holding managed or managed holding native, are there equivalents if you're building against WinRT?
That's a very excellent question. So how many of you know what pinputter is? Okay, so quite a few C++ CLI developers. It's not there, so I lied. I didn't lie. I was correct when I said one thing changed, which is GC new becomes ref new, if you're thinking of C++ CLI to this syntax. But one or two things went away that just don't matter anymore, which is pinputter. It's not moving. So because the pin was to keep it from moving. So some of those things are not necessary anymore. But largely, everything you've seen in C++ CLI is exactly as you've known it, and just respell GC new with ref new.
Well, you said that you are generating code from XAML. The question is, in other languages, this prevented visual inheritance because classes couldn't be inherited from XAML-generated class. In C++, you also have multiple inheritance. How did you fix them?
So this is based on COM. And WinRT, I mean. And how many know that COM doesn't have inheritance? WinRT COM does. So one of the things you can do is actually in C++ inherit one graph class from another. Single inheritance, not multiple inheritance. But go find out more about that, because there's a lot to be said about that feature, and it's very useful, especially in exactly the situation you're talking about, which is UI frameworks. And that is actually made use of in part of Windows 8 for the UI framework, where you do actually inherit from WinRT classes. I said this wasn't your granddaddy's COM anymore. One more, please.
Yeah, can you use the concert in these Metro apps, or does the WinRT have its own sort of implementation of TPL?
He heard it, but I didn't hear it.
Can you use concert on these apps? The concurrent runtime from C++, or is there a WinRT implementation or like TPL that you use?
So can you use concert, the concurrency runtime, PPL, all that stuff we did? Absolutely. We really meant it when we said use whatever you already have and it just works together. So if you want to write a single function that uses a WinRT type that does a .then to use with a concert parallel loop and futures and all that kind of stuff, that'll all work. It's just different kinds of types that you consume from different places. They may have different formats, but you just use them together. We know how to bring them in together. In particular, Concert and PPL also have further improvements. I'm not sure offhand if there's a talk about that at this conference, but there is. Let me just check. Is it one of the ones on Channel 9? I'll have to look. I can't do it on the fly. But there are enhancements coming to PPL, and in fact, there have been some recent blog posts from the parallel computing team and on VC blog that have been talking about those just in the last few days. So not only can you use it, but there's even more there. We've invested there further as well. Yeah. So thank you very much for coming. Enjoy the rest of the conference. This is going to be a really, really great week. Thank you very much.